There we go. All right, can everybody see that? All right, ready? You guys are called E class, aren't you? E. All right. So, all I ask you to do is to relax a little bit, relax your mind, and say, I'm going to listen to what you say, and then, oh yeah, that came back to me. Oh no, I forgot that. See that? And just make little notes to yourself. All right, so what we're doing, this chapter is about chemical reactions, all right? And we're really getting into that next level of chemistry. Once you can write chemical equations, we can start doing real chemistry. You can start doing real chemistry and then change it into cheminese and balancing the equation and figuring all that out. And then our goal after that is to add some mathematics to it, and then you'll be doing what they call stoichiometry. All right, so here we go. Think about some vocabulary words. If you were writing this test, what vocabulary words would you put in there? We had this at the beginning of the year. What are chemical symbols? What do they represent? What do chemical symbols represent? There's a bunch of them right here. And those are called elements, right? Or atoms. What about a chemical formula? What does that represent? We had a whole chapter on that. Compounds. Very good. And then what do chemical equations represent? If you see this, what does that represent in the real world? I'm looking at your faces, okay? What do you think? Anybody? It's written on here, but chemical what? Reactions. See that? So this represents an actual chemical reaction that takes place. We have the word reactants. Reactants are things that are going to react, and we find them on the left side of the arrow, don't we? So these are the reactants. Just coming back to you a little bit. Yes, I'm looking at you. Is this reactants? Yes. What do you call the things that are going to be produced? Products. Okay, they're on this side of the arrow, aren't they? And what about some symbols? What is a little s? What's that little s stand for there? What does that AQ stand for? What does G stand for? Is that coming back at all? S means zinc is in the form of what? It's a solid. And the hydrochloric acid is dissolved in water, right? All acids and bases are dissolved in water. And then what about this stuff? Zinc chloride, is it a solid? No. It's dissolved in water, so what's it going to look like? It'll look like water, won't it? I mean, sometimes it has a color, sometimes not. And what about this going to look like? What's that little G? It's going to look like bubbles, isn't it? You think little bubbles getting produced? Okay. All right, next. Don't forget that the arrow, some people say the arrow means yields or produces. Yes?
I had a question about the symbols.
Yep.
Are you always going to have two aqueouses in a reaction?
In this chapter, I might ask you to do it a couple times. In the next chapter, it becomes a little more important. But in this chapter, are you saying I'm not going to make you do it? No.
No, I'm asking, in a chemical reaction, do you have to have one on each side of the arrow?
One what, though?
Aqueous.
No. Now, it is true, I could have two aqueous solutions, and I still, well, that's a good question. You're saying if you have an aqueous here, we always have an aqueous here. A lot of times you do. That's a great question. It's beyond what I'm teaching right now, but it's possible I could have one aqueous on the left and none on the right. It's possible, but usually not. Okay. Next, so the arrow means yields or produces or makes, forms. Everybody get that? So when we're trying to change from English into cheminese, that's what you might say. You say, well, I saw this plus this, and it formed this, and that means arrow. All right, next thing is that when we write this down, and I talked about Lego pieces, if I just write down the way I wrote it here, one of those Lego pieces plus one of those little guys, I couldn't make this and this. I couldn't. So what's wrong with that equation? It hasn't been balanced. And what does that mean to balance an equation? What do you think about that? Remember that word? I'm looking at you, I keep looking at your faces, but I can't, you're not giving me any indication. When you balance an equation, what are you really doing? Aren't you saying, like, look over here, look on the left side there, I had 1 zinc here, but I end up with 1 zinc. That's balanced, isn't it? I started with 1 chlorine on the left, but I ended with 2. That doesn't balance. That's not correct. All right? How do you come up with 2 chlorines when you only start with 1? So that's when I was trying to teach you little tricks on how to add these coefficients. Oh, another vocabulary word. So you add a coefficient, don't you? And the coefficients make the story make sense. When you put the coefficients there, this plus 2 of those, I could make that and that. And that's why you balance an equation with coefficients, right? What set of numbers do you never change when you balance an equation? What set of numbers do you change when you do want to balance an equation? They're called coefficients. But what set of numbers do you never change when you balance an equation? The subscripts, right? Is that right? Okay. So if I'm going to balance this, I cannot change HCl into HCl2. I can't do that. The other thing I want you to get used to is, why do equations even occur? Well, tomorrow when I do the demonstrations, I'll show you an equation. I'll show you one where one of the products is going to be water, and that's like a driving force. It kind of makes the reaction take place because one of the products is going to be stable water, like that. Another one is production of gas. You'll see that one. And that makes the reaction tend to work. Because otherwise, you could put 2 chemicals together and nothing could happen. Nothing. There's no driving force. The other one's called the formation of a solid. That's where you don't start with a solid, but all of a sudden there's one there. That's another one. And the other one, I'm going to wait until next chapter. I'll write it down for you, but it's really something it's a higher level one, and we'll be talking about that in the next chapter, and it's called transfer of electrons. And I really would like to just wait on that one, and I'll show it to you next chapter. But I think you should at least understand that these are the 3 at the beginning that kind of tell me that that's gonna make the reaction take place. Okay. Now, in first year chemistry, I usually keep it to 5. There's only really 5 types of chemical reactions in first year chemistry. There are really more, but we only do 5 right here, okay? And look at synthesis and say, synthesis, I remember that word. Synthesis means what? When you synthesize something, you take something simple and make it more complex, don't you? Is that right? Okay, so you actually make something, don't you? And so it's like A plus B equals AB. Everybody got that? Okay, now what's the opposite of a synthesis reaction? Instead of forming something, what if you were to break it apart? What's that called? Decomposition. Does that make sense? Now, the one thing I like about decomposition is how many reactants do you have? Here I had 2 reactants in a synthesis, but only 1 product. What about here? 1 reactant. And so a lot of times you'll start with 1 chemical and it'll say heat it, electricity, use a catalyst, and it'll decompose. So that's called decomposition. Single replacement. Here you usually have a single element and a compound. The single element, if it happens to be a metal, the metal will kick out what? The metal or non-metal? The metal will kick out which one? The metal. So if A kicks out B and B's by himself, A will be written first because in an ionic compound, it's the cation is always written first, the metal ion, right? Okay, so and this one would be the same equation, the same classification, except here D kicks out C. So that's still single replacement, but D is probably a what? A non-metal. Because when you wrote it, BD, it was written second, wasn't it? D was written second, so it must be a non-metal. Okay, double replacement. And did everybody fix that? Whoever typed this for me, I give them credit for it, but I didn't check it. Did everybody change that to AB plus CD? Did everybody change that? Look on your papers. Did everybody change it? Okay, equals AD. So here, the metals kick each other out, and then and they form two different compounds like that. That's called double replacement there. And now I think the hardest one to belong to the club. Hey, how do you belong to the combustion club? Hey, number one, do you have at least carbon and hydrogen as one of the reactants? It could be carbon hydrogen compound or carbon hydrogen oxygen, but do you have at least carbon and hydrogen in you? Yeah, I do. Are you going to burn it? And what's that mean in chemistry? It means combine it with oxygen. Okay, number two. And what's number three? You have to form carbon dioxide and water as your products. If you pass those three tests, you can be called a combustion reaction like that. All right. Are you okay so far? Do you think more is coming back to you than you thought? All right, so now what I'm going to do is, let's classify for a minute. I'm going to cover that up and go through there, and do you see kind of like an A, B? See that polyatomic ions like a B? See? AB plus CD, is that what are you seeing that or not? Do you see how A kicks it? Oh, yeah, okay. What would you call that one without looking? Double replacement, all right? And what about this guy? You know what makes this harder to classify? And I had a trick for you. What I said was, if you ever find hydroxide on one side of the arrow and water on the other, if you wrote the water as HOH, now can you classify it? Let's see, hydrogen kicked out sodium and formed HOH. But sodium kicked out hydrogen and made NaCl. Everybody with me? I'm not getting a great look from your faces. So, are you okay on this? You have to stop me. Do you see that as double replacement? Okay. Now, down here, do you see iron and oxygen coming together, synthesis? Do you see that? Most people on this test, and you know what? I am going to put a little pressure on you, okay? In the past, the last 5 years, this test here you're going to take on Friday has been one of the highest average tests that I've had all year. I'm going to put some pressure on you. But what if you're going to do well. You get it? You're going to do well. You get it? There's no reason that you won't do well. A little pressure? You like that pressure? You'll be all right. You know what? You're going to do well. Okay. Now, after you classify these, excuse me, that's some synthesis. Let's go over the tricks. I think I had 4 or 5 tricks on balancing, okay? I don't have a trick for every equation, you get it? But let me tell you the most likely trick you're going to use. Let's go down to number 6. As I scan through that, I notice that says O2, but this says O5. This is called an odd-even mismatch. If you want the number of oxygens on this side to equal that, an odd number will never equal an even number, will it? But my trick is, what's the smallest number that 2 and 5 both go into evenly? 10. So 5 times 2 is 10, and 2 times 5 is 10. That'll do it. Now, remember, if I put a 2 there, it not only means 10 oxygens, but it also means how many phosphorus? 4. So I go over there and put 4. And you always check to see if it can be reduced. Can this one be reduced or not? No. I can't divide everything by the same number, right? Nope. What about this one? What are you supposed to do if you don't have to put any, there are already coefficients of 1 on there. It's understood 1. What if you don't have to change, what if you don't have to write any coefficients in there? What are you supposed to write? I require you to write the word balance, so then I know you looked at it and you saw that it was already balanced. I'm not going to write balance on this one because I balanced it. I didn't have to do anything to that one. That's when I write that. All right, so trick number 1 is the odd-even mismatch. Yes?
When you talk about reducing, you're talking about reducing the coefficient.
Yes, yeah, excellent. When you say reduce, you always look at the coefficients you just put in there, all right? As a matter of fact, when I look over here, if I look through here, here's a 1 coefficient, a 2, a 1, a 1. Anytime you have a 1 coefficient, even though they don't write it, it's done. You're done. You can't reduce 1. Got it? So here, what if you had put 8, 10, 4? If you put 8, 10, 4, then would you recognize that? Would you recognize you could divide all those by 2? Then that's how you would reduce it. Good point there. All right, trick number 2. I'm going all the way down to number 9. Am I on the screen still? Yeah. Sort of. All right, number 9, ready? Scan, scan, scan. And then. Hey, did sulfate stay as sulfate? Yes. Okay, so I'm going to balance my sulfates first. And how many sulfates do I have here? Please don't say 4. How many sulfates? 1. Okay, now, how many over here? 3. So I'm going to put a 3 here. That gives me 3 sulfates, but it gives me 3 coppers. 3 coppers. And then I had 2 aluminums right there. Can it be reduced? No, see? Can't be reduced. Yeah? Okay. All right, so trick number 1, odd even mismatch. Trick number 2 is if the polyatomic stays the polyatomic, treat that as a single atom in a way, and then maybe balance that one first. That usually helps. Trick number 3, if you see hydroxide on one side of the arrow and you see water on the other side of the arrow, write the water as H2O. It'll be way easier to balance and easier to classify. You okay with that one? Okay. Here's another trick. Let's go to another trick is if you have like oxygen all over the place, like it's here, don't do that. Don't try to balance oxygens first. Leave that to the end, okay? And the other one is for combustion. Okay, so here's the biggest trick I can help you with. If you have a combustion reaction, okay, see this 18 here? If it looks like you're supposed to put an odd number in front of the water of a combustion reaction, what are you supposed to do? Because you'll never balance it. If you put an odd number in front of the water on a combustion reaction, it won't balance. So what do you have to do with that number? You double it. And now if you do that, it's going to be simple. 18 times 2, 36 hydrogens, 16 carbons. And by the way, do you know carbon dioxide is C1O2? Does everybody know that? So how many carbons do I have there? 16. How many oxygens do I have? 32. So I have 32 oxygens here, 18 times 1. I have 50 oxygens on the right-hand side. How am I going to get 50 oxygens over here? Put a 25 right there. Okay. Now, the hardest part are these. And have we done any of these in this class? Did we do? Okay, you said we did do some of them? Oh, I must have written on the wrong one. We did them in class, or I just told you to go to home, or... This is kind of a minor, even though this is kind of a minor part of the test, even though it's maybe 10% of the test, this will be the hardest part for a lot of you, okay? The rest of it, I think you're going to do well on. But let's take a look. Let's do one at random. What do we do, like 1, 2, and 3 or something like that? All right, let's do 4, okay? Let's do 4. Now, you know why these are hard. Okay, you have to know what you're talking about to do these. Let's try it. You've been gone for over a little bit more than 2 weeks. Could you write the formula, for potassium chlorate? Oh, polyatomic ions. I better go. Yeah, you better study those. That's right. Okay, what do you think? Anybody remember chlorate? Hopefully, not everybody. What do you think? What is it? And what's the charge on chlorate? And what's the charge on potassium? See, I already feel good. So I'm not even going to think about balancing until I got my formulas right, don't I? Gotta get the formulas right first. Potassium chlorate, when heated, I could actually put that, couldn't I? where do you put things that are not reactants and are not products? You put them on the arrow, don't you? And yields potassium chloride. How do you write potassium chloride? Potassium what? Chloride? You mean just chlorine? Yeah, that's what I said. You okay with that? Is that how you do potassium chloride? By the way, you're not getting around that. I gave a retest, but you're not getting around not how to do right formulas. You get that? You have to be able to write formulas the rest of the year. Got it? I'm not going to make up for that. I'm not going to make excuses for you. And what's the other thing? Oxygen. This? That? Huh? Huh? What's that? What's that about? Why did I do that? Okay, what are the diatomic elements? Here we go. Ready? What are the diatomic elements? Oxygen, nitrogen, hydrogen. There's the gens. What about the enes? Chlorine, fluorine, iodine. Oh, bromine. What do you think? You remember that? Now, don't get confused. You thought, why do you have O3 here? That's not oxygen. That's not oxygen. That's potassium chlorate. What if I have the element oxygen? Then it's O2. You get it? You can have 15 oxygens in a compound. But what if it's just the element oxygen? Then it's diatomic, isn't it? All right, now we're ready to balance it. See? You don't balance an equation until you have it. So go ahead, and I can... you look really ready today. Not really, but you look a little tired. But can you classify that for me?
Classify it?
Yeah. What do you think? You don't need to look at that paper. Come on, you can do it. You can do it. Look at here. What do you think? What looks like happening? You got this chemical and it's blah, 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 blah. It's breaking down into... Yeah, very good. See, decomposition. Now we're going to balance it. Anybody see any tricks that might work? What do you think? Any tricks? Yes, no? You got to recognize them. Do you see any tricks here? I do. O3, O2. I know how to fix that. What's the smallest number that those numbers go into? Evenly. 6, so 3 times 2 is 6, and 2 times 3 is 6, yes? Let's try it now. 6 oxygens on the right-hand side, 6 oxygens on the left side. But how many potassiums does that give you? 2. But wait, that gives you 2 chlorines also. That's right. Now, can it be reduced? Okay, I'm done. Ding, 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 ding. Yeah. Okay, let's let you try number 6. You by yourself. Again, even though this is only about 10% of the test, it is the hardest part of the test. But not for some of you. Some of you said, I know how to write formulas. I didn't forget that. I know my polyatomic ions. I didn't forget those. Six is kind of a hard one because also you have to remember how to name acids. Oh, how do you write formulas for acids? So tonight you say to yourself, I can spend 30 minutes on chemistry a day tonight. I can take my packet and I can spend 30 minutes on it, or I might spend 10 of those minutes looking at my polyatomic ions, or 5 minutes looking at polyatomic ions. All right, who's gonna help me here? Who can do this? Tyler, think you can do this one? All right, real loud in a loud voice. How you gonna do it? Yeah. Very nice. All right, move on. Oh, this is a hard one. Phosphoric acid. Has a famous phosphate in it, doesn't it? Wait a minute. It's not an acid yet. How many hydrogens? If phosphate's -3 and hydrogen's +1, how many? Okay. There's your second hurdle. You've gone over 2 hurdles. Yes, very, very good. Okay. Now, if you want, because hydroxide's here and water's here, if you want, it might help you to write. I'm not forcing you. It might help you to write water's HOH, okay? All right, let's balance it. Ready? Scan, scan, scan. Hey, phosphate stayed as phosphate and hydroxide stayed as hydroxide. So you can do either one of those. I think I'll do the phosphate first. 2 phosphates, only 1 phosphate. Got that? Are you okay with that so far? All right, now, I noticed how many hydrogens are not in hydroxide. I know I'll have to deal with those, but how many hydrogens do I have that are not in hydroxide? 6. There they are. There's the 6 hydrogens that are not in hydroxide. But how many hydroxides does that give me? 6. 2 hydroxides, 6 hydroxides. What are you going to do? 3 calcium. Oh, it worked out. It worked out, didn't it? Now, can it be reduced? All right. Max is going to classify this one for me. Watch, he's going to do it. He can do it. No pressure. AB, calcium hydroxide, AB plus CD, hydrogen and phosphate. See how they're changing places?
Single replacement?
Single or double?
Single?
Calcium did kick out hydrogen and form a compound with phosphate, but hydrogen also kicked out calcium and made what?
Water.
See that? So what do you think?
Double.
Yep, double replacement. All right, do number 7. Number 7. Okay. How about Danielle? Danielle, how about, what do you got?
I did CU,
Excellent. Very nice.
That yields CuSO4.
Sulfate was -2, and it said copper 2, didn't it? Okay, that's good.
Plus HOH.
And I can do HOH, but remember, there's no hydroxide over here anyway. I wouldn't necessarily make it HOH unless I saw a hydroxide over here. Get that? I'm gonna leave it as water, okay? What's the next one?
SO2.
All right. Now, I can tell you right now, this could be easy, but it could be one of the most difficult ones because what happened to sulfate? Did it stay as sulfate? No, it got broken down, didn't it? So that means that I can't balance sulfates, can I? So now I got to balance sulfur atoms, don't I? All right, let's take a look. How would you classify this one? And you know what? I'm going to say I won't put this on the test and say classify it because it doesn't really fit very well, does it? It looks like the copper is kicking out the hydrogen, so it looks like single replacement. But it also looks like there's a little decomposition going on. So I won't ask you to classify this one. Everybody get that? It looks like it's a combination of a couple things. But how do you balance something like this? This is not going to be easy, I can tell. What do you think? See anything weird happening here? Does anybody have an idea? Does anybody already get it done? What do you think? Okay, right now I have one copper, one sulfur atom, 1 plus 1, 2 sulfur atoms, 4 oxygens, plus another one, plus 2 more. I'm not going to balance oxygens first, so what do you want to go after first? Oh, I might have to. All right, what do you want to do? What do you think? I can tell you right now, no matter what number I put in front of here, what's any number times 4? Even or odd? Even. So somehow I have to make sure these are even over here. Get that? This is going to be even. No matter what I put here, it's going to be even. Now I could do this. Does anybody know what even plus even is? What about 2 plus 4? Even, isn't it? Even plus even is always even, isn't it? Anybody know what even plus odd is? Odd, don't do that. Don't have an even and odd here. Get that? That'll be an odd. Odd plus even? Nope. What's odd plus odd? Ooh, I never thought about that. What's any odd number plus another odd number? Even? I could do that, couldn't I? So I could have any number, even, any number, odd, couldn't I? So what do you think? Anybody want to go after this one? This would be one of the, not easy, this would be called medium to hard. This would be kind of a, any ideas? I'll tell you what I do sometimes. I put a 2 here. That'll automatically give me an even number of oxygens. Let's just see what happens with that, all right? 4 oxygens plus how many? 2, right? Plus 2, what's that? 4 plus 2 plus 2. That's 8. 8 oxygens. Now let's try that. What would happen if I did that then? Would that give me 8 oxygens? But that would give me 2 sulfurs, wouldn't it? But how many sulfurs do I have? I do have 2. Oh, looking pretty good so far. But how many hydrogens does that give me? 4. Oh, I'm lucky today. It's kind of trial and error, isn't it? But I was pretty lucky on that, wasn't it? Sometimes I put a 2 in front of water because I just don't like an odd number of oxygens anyway. And can I reduce this? All right, what do you think about that? That was probably the hardest one so far to balance. All right, let's try number 8. Let's see if you're getting a little better. Getting a little bit better? A little bit better? And remember, changing English into Cheminese is only about 10% of the test. So don't walk out of the room thinking, well, the whole test is going to be like this page. No, it's not. You get to be, when you can do this kind of stuff right here, you're getting to be a pretty good chemistry student. And then by the time we add mathematics to this, you're going to be really good. Right, I'm getting there. All right, Caroline Fox, you can do it. You can do it, right? Confidence. Okay? Help me out.
I did
H
plus
plus what?
N
Say it again.
O.
N-O, capital N, capital O? Okay. What do you think?
H2O plus N.
Okay, and plus what?
N.
Okay. All right. Now, how confident are you at this point? Pretty confident? Okay. Now, raise your hand if you think that she has this right. All right. Now, I love your confidence. I want you to be confident. But what is something that I'm going to give you a chance to fix this? Something we said today that had to do with one of these other ones. And if you just remember that one thing, you'll be able to fix it. Think about something we talked about before. Okay, that's fine. You know, again, we've been gone. All right, Kayla, what do you think she did wrong? That's fine. Hey, see? All right, John, what did she do wrong? What was it?
It's a diatomic molecule.
Diatomic element? Are there diatomic elements on the planet? How do you know which ones are diatomic elements? Remember that? Okay. So is hydrogen one of the diatomic elements? So if you had a balloon full of hydrogen gas, it wouldn't be H. It would be what? See? What do I breathe? I don't breathe O. What do I breathe? O2, don't I? All right. This is correct. Now this is correct. Now, nitrogen, remember? Hydrogen. See? Do you know that 80% of every breath you take is N2? 80%. In, out. Okay, now we can balance. So don't ever try to balance an equation unless you have all the formulas correct, all right? All right, anybody see any tricks here? What do you think? What do you see here? Scan. 2 hydrogens, 1 nitrogen. Oh, 2 nitrogens? Okay. See, fix that. Now how many oxygens? 2. I can fix that. 2. Uh-oh. How many hydrogens? I can fix that too, can I? Now, can I reduce it? Oh, you thought so, but there's a 1 there, isn't it? So I'm done. All right, what do you think? Okay, let's do one more of these. Let's go back up number 5. That'll make you feel a little better. I think you can do this one. Let's do number 5. But you have to admit, I think, are you getting a little bit better? Are you feeling a little bit better than you did at the beginning of the class? Well, wait, today's Wednesday. I think I'm going to be in good shape by Friday. All right, Noah Ramos, you look confident, huh? Are you confident? You can do it. Number 5, go. AL what? 3? What made you do that? Wait, what made you say AL3? So you mean AL with a subscript 3? So is that like triatomic aluminum? That means 3 atoms of aluminum have to be together. So right now, we do know about some diatomic elements, but right now, I haven't really mentioned triatomic elements. So if you just say aluminum, just say, if he's not a diatomic element, just say AL, okay? All right, go ahead. What's next? Yes. And HCl is hydrochloric acid, right? Okay, go ahead, John. Not John. Noah. AL what? Okay, ALCL. Okay, and what? H is H. Okay. All right. How many? Raise your hand if you like with that. You like it. All right. So now we got to figure the mistake. So let's see, Elizabeth. Tell me one mistake you think you see.
There needs to be 3 chlorines because aluminum has a charge of +3.
So aluminum in a compound is +3, right? And chlorine's -1, so you're correct. I would need, is that right, Noah? Don't I need 3 chlorines to make aluminum chloride? Okay, and then, so that's okay. All right, do you have another, just find another mistake?
Shouldn't hydrogen be H2?
What? What made you say that?
Because it's a diatomic element.
Diatomic element, right? Okay, so, Noah, remember that? No, remember that? We said talking about diatomic. Make sure you know your diatomic elements, okay? All right. Now, is this correct? Is that aluminum? Yeah. Is that hydrochloric acid? Yeah. Is that aluminum chloride? Yeah. Is that? Yeah. So now we can balance it, okay? Anybody see anything weird going on here? I don't see any real weird things. The first thing I noticed is probably I could put a 3 here, couldn't I? But you know what's going to happen? If I put a 3 here, that'll give me an odd number of hydrogens, and I already know what. It's got to be even, doesn't it? So it all depends on how you want to do it. If you put a 3 here, and this is trial and error, isn't it? You're going to quickly figure out you have an odd even mismatch there, aren't you? So then you're going to do what? Aren't you going to do that? Is that what you're going to do? So you get 6 hydrogens here, 6 hydrogens here, 6 chlorines here, but only 3 here. Okay, and that gives you how many aluminums? All right, now you gotta always check to see if it can be reduced. Can it be reduced? No. All right, and Caroline, tell me, how would you classify this one?
Single replacement.
Yeah, the aluminum kicks out the hydrogen. There it is, see? And single replacement. I like that. All right. And you said we did the other 3 in class. Are you sure?
No, we didn't.
We did what?
As
We didn't do 3?
No, we did. They were separate groups.
We didn't do it as a class. We went in small groups of 10.
Oh, okay. I wonder why it was blank. I wonder why it was blank in my thing because I looked at your. Okay, let's do. All right, let's do number 3. Let's do number 3. We have about 2 more minutes. Let's do one more. Let's do one more of these. Again, tonight, if you tell yourself 30 minutes for chemistry, and I can get myself caught up a little bit, take a look at some polyatomic ions again, maybe look acids, you know, how to name acids. Who was in that small group that already has this done? So I won't call on you. 1, 2, 3, 4. Okay. All right, I won't call on you, sorry, because you already have it done, all right? Matt, you have this done? You already have this one done? Wow. You did it by yourself?
No.
You were in that group? Oh, okay. Ty, you don't have it done yet, ready? Okay, go ahead, keep working. So we got about 1 more minute. Ty is working hard. Look, he's working very hard. All right, Ty, we got to start, so I'm ready.
Okay, I'll start with Na3 and phosphate fuel.
Okay, so phosphate was -3 and sodium's +1, so that's why you had to have 3 sodiums, right?
Yes. And then I did plus CaCl or CO2.
Okay, so calcium's -1. I'm sorry, chlorine's -1. Calcium's +2. That's why you had to have 2 of those. You're in good shape.
And then I did yields C83 and then PO4.
Okay, so if that's -3 and you're +2, then you have to have 3 of those and what? 2 of those. We're almost there.
And then I did plus NaCl.
And -1. Oh man, that's great. That is great. First of all, if you can write the formulas down, now you can balance, okay? Don't ever try to balance it before you write the formulas, okay? All right, anybody see quick tricks? I'm moving on about 15 seconds. Ready? Zoom, 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 zoom. See the phosphate? 2 phosphates, 1 phosphate. I can fix that. How many sodiums does that give you? 6. I can do that. But how many chlorines does that give you? 6. Now there's 6. But how many calciums does that give you? Oh yeah. Can it be reduced? Okay, you can leave if Noah tells me how to classify this one. One more time? No, I guess we're not leaving. Now, can I tell you something? If it's single replacement, would you have to have a single element and then a compound? But we have a compound and a compound, don't we? What's the answer? Okay, all right. Thank you very much.